Our presentation is on stream flow analysis and how concrete obstructions in biogeomorphology might potentially affect the stream flow.
So for our abstract, we investigated a section of Bee Creek that is located at 1409 Angelina Circle in College Station, Texas. This section is 90 meters long and located 10 meters from the northwestern property boundary. Its width ranges from about 1 meter downstream to about 8 meter upstream. There's a flood control barrier made of cobbles, boulders, and bricks that existed since 2008, but that has been overgrown over the years. In fact, you can see in the center the cobbles and boulders which are still exposed, although for the majority of the section it has been overgrown. So this section will be the extent of this project. Our goal is to build a biogeomorphological profile of the stream in order to map a 100-year floodplain. We are going to utilize a combination of real-time kinematic RTK, global positioning system GPS, and HECRAS, which is the Hydrologic Engineering Center's river analysis system.
During our research, some problems that we faced, one of which was classifying biogeomorphology. We weren't quite sure how we were going to classify whether or not an obstruction would help with soil stability or hurt soil stability, but that was quickly rectified once we went to the actual site itself. We were able to better tell where flooding occurred based on where flattened grasses were and just get a better understanding of the type of obstructions that were actually there. Another problem we faced was uploading to HECRAS. Our upload was incomplete, and this just meant that we ended up sticking with our data that we got from Civil 3D.
So for our methods, we pretty much did everything down the bullet points on this. We grabbed a research team, equipment, had to get some survey wardrobe, which included, waterproof shoes because we were down in the creek measuring, taking points for our data. We had to make sure everything was operational. We, turned everything on, looked at it all, made sure it was doing the right things. Once we got all of our data, we uploaded it to Civil 3D. We attempted the HECRAS, it just didn't go the way we wanted it to. We then uploaded to Civil 3D, and the end goal was to create the 100-year floodplain. But we ended up just sticking with our cross sections, which you're going to see in the next slide.
So here are the things that we were able to create with Civil 3D. On the lower right, we can see a topographic model of Bee Creek. We used all of those points from surveying, as just said, and we created some contours and put some sample lines along the river to create these cross sections on the left. As we're reading the cross sections, if you look at the right side of each cross section, we can see that elevation stays pretty much the same throughout Bee Creek. And we determined that it's because of the concrete structural brick and the trees holding the shape of Bee Creek along this side. And then if you look at the other side, the left side of the cross sections, we can see that elevation changes pretty drastically throughout Bee Creek. And that's because there are no concrete structural brick on this side, nor are there trees.
So in conclusion, despite us not being able to input our data into HECRAS, there were some things that we were able to assume about the creek channel in Bee Creek. So based on the data that we collected, obstructions contributing to higher rates of flooding included vegetation within the creek channel and boulders that were also within the creek channel. Obstructions assisting in soil stability included trees on the creek banks and the concrete pavers on the creek bed of Bee Creek. And as a professor once told me, Always practice safe geography and always use a projection.